again, everyone. My name is Yemi Ayola. I'll be your tutor for manual testing. I'm going to tell you some rules, so I'm taking you through manual testing. And in this class, there are things I'm just expecting from you, my students, and everyone in the class. If you've if you've got any question while I'm lecturing, just pop it on the chat so that you don't forget it. Pop it on the chat because I'll go through all the questions when I finish. Also, I would please, if you can please mute yourselves so that until when we finish the class, when you want to unmute, you're fine. Or when I ask some question and I tell you to unmute, people can do that so that we'll have you'll be able to, when you go back to the audio, it's kind of easier for you to be able to hear what I've been saying. And the other thing is that in the class, please, just two things. Your full concentration is needed. I'm not going to take much of your time. My classes are planned. I know what I'm going to give you at every class. So just your concentration will be will be great. And also any little, if you can jot down, it will be nice. I know you still have the videos and things like that, but if you can jot down. And please, there are no silly questions. You can ask me any question at any time. I'm ready to go back to understand. And have it at the back of your mind that in this manual testing class, that's the bed rose the foundation for testing. Mainly, in fact, the main phase of testing. Even if you're doing automation, doing everything, if you don't understand the process and procedure of what I'm going to give you regarding manual testing, it will be kind of difficult when you start working. So yes, so that's just the rule. Please remember, ask me any questions. So I'll start today. As I've said previously, we're in a manual testing class. I'll be introducing you to mainly every process, the procedures that we're going to do. So today, these are our topics for today. So I'm going to start with the background. Background meaning giving you different phases, how testings are done. I'll tell you different roles in the testing. I'll tell you our objectives. I'll talk about general principles of testing, and the final one will be fundamental test process. So these are the topics I'm teaching today. So let's go first to the background. So why this background? You'll be wondering that. Well, let me first say, for you to have been in this class, you've made the right choice, and you would know the reason when I start lecturing. So the background, let's take that background at a face. So let me take you away from the IT world. Let's go to the normal world. So most of the time, testing is done on daily basis. Every time you can't. There are different forms of testing that we do. Let's take an example. If you go to the market, maybe you want to you want to get an item. Let's take an example of a mobile phone. You get to the phone shop, you want to buy a phone. There are different features in this phone. You might have maybe a latest version of the phone, I mean, a previous one. You want to check the new one. The first thing you need to do is to test all the features, the new things that they have there. Predominantly, what you're doing at that time is that you're trying to check, you're testing all the features. Oh, they said it's got a new camera. Let me see, how is the camera different? So they will give you all the responses of the camera, what it entails. That is a previous avenue to say you're testing. Let's bring it to the world of ourselves. If I ask you, please, I want to drink a cup of water. Please, can you make it room temperature? Room temperature, not that warm or cold. So, How do you want to check it? If I give you cold water and I give you warm water, the way to test it is to bring them together, measure them, pour it in your hand, feel it. Is it room temperature? Temperature? Is it too hot? Is it too cold? What you're exactly doing at that time is that you are testing. Let's take another thing is that take an example that you want to write and you need a pen. Hear me, please. Can I have your pen? Even if it's working, just that conscious bit of it. You want to sign a document. You first scribble on a piece of paper to be sure that is writing before you sign it. What you're doing when you're scribbling it, checking, is that you're testing if that pen works. That is another form of testing. Let's take another example. You and I, when we sleep and we wake up in the morning, we do a form of stretching. At that time, what you're just trying to do is also to test, oh, my body, move your hands, move your legs. It's another form of testing. So let's bring it back to IT world. We've got various things that can be tested. Talk about softwares. I've talked about mobiles, phones. We've talked about there are different applications. Everything will be mainly on your screen for you to test. Of course, there are some places that you do physical testing. We'll come to all that. So that's mainly the main background of testing. So I'll just give you an example. There are various examples that you can do, but the example I'm looking at today is that if you want to buy, I'm using a new car as an example. So in a new car, if you want to buy a new car, the first thing is that you will first book like you want to go to the showroom, you book the way it's done here. When you get there, you want to test drive it. Maybe you've ordered for a particular brand of car. The first thing you need to go when you get to the showroom, there are different features in the car. You want to see that it's a fully compacted, clean car. You've ordered for a blue car. You don't want to see a green car. They won't even give you a green car. So it should be a blue car because that was the specification. You've ordered to see a non-stainless car. Good. Got the 5 doors. If it's a 5 door, you've got you've got the windscreen. It's got the engine. You've got different features in a car. You don't want to get to a showroom to now see that one of the door, maybe the driver's side, the door is off. There's no door there. No, you don't want to see. Or you don't want to see a dent car when you get to the showroom. So that's an example of a way testing is done. So when you get to the showroom, the first thing you want to look at, does the car have an engine? You go into the car, on the ignition, does it have a brake? You can check it. You can drive it around. You can see that, yes, it's got a windscreen, it's got the lock, it's got 5 wheels, it's got 5 doors. So all those features are the things that we test when we want to buy a car. And everything that you need to test will be written in the manual. There's a blueprint, a rule book in the car, which is the manual. So it will be documented. Everything, every features that you need in that car will be in that manual. So that's an example of testing that I've said in various forms. So we've got more examples in the textbook. And before I go further, we've got the soft copy of the textbook, the manual testing textbook. I would I'll tell the admin to send a copy to the group. You can read ahead of the class. We've just got 6 topics in that book. So you can read, and those 6 topics are what we are going to treat also here for you. Oh, so that's the background. You see various examples there. in the textbook. So that takes us to the next phase of it, is that what are the different roles in software testing? So now I've looked at it. The main class we are here today is manual testing, but I used another word to say different roles in software testing. So manual testing can be called different names, but we still do a particular thing. We are still testing. As a manual tester, you can be called a quality assurance engineer. You can be a UAT tester. UAT meaning user acceptance tester. You can be called the test analyst. You can be called a manual tester. You could be called a web tester, a QA, that's quality assurance test analyst. You can see the first one was an engineer, that's mainly both manual, automation, everything. This also includes it. Functional tester is still it. Software test analyst, agile tester, automation tester. So these are all forms, different roles. You can be called a pen tester, security tester. There are different names, but the main thing here is that our role is to test any application, software we are being given, and make sure that at least they're bug free. That's the major thing that we as testers have done. After looking at all these various roles, don't see it as big names. They are just titled to that manual tester. And you will see the role. Because at the end of this course, our expectation is that you can start looking for a role as a manual tester as long as you have gone through the rigor of this internship. So I am very certain if you're diligent, if you pay attention, do all your assignments, I will tell you it's very easy. It's very easy out there. So you will get the right job. It's just for you to be diligent. Make sure, devote your time. 2 hours a day, an hour is fine. So what are the skills of software tester? So now if you're here today, there are certain skills. If you see those traits in you, know that you're in the right class. These are the so today the main skill that you need as a tester is to be able to test. That's the major skill that you need. Every one of us, be you automation tester, be you manual tester, be you a web tester, quality assurance engineer, anyone, any role, software tester, our major role is testing. Now we have bit of it, software tester, system, all still boils down. All the skills that you see still comes under testing. So those are the major skills that you need, mainly testing. And you will see in the course here, we will teach you how to the systems that you're going to work on. You have the application you're going to work on. You are a software tester already. Test planning. We are going to that. I'm going to teach you how to design a test plan in this course. SQL is mainly database validation, and you'll be taught that automation testing, that is going to be part of that. Product knowledge, that's it. Microsoft Windows, those are the tools that you're going to use. And we've got at the web application. So by and large, the major skill that you need here is testing. I'm still going to take you further to. So, if you have been looking at, oh God, am I actually in the right place? Am I doing the right thing? Is this job lucrative? How's the salary expectation? So, I've taken a graph of what our expectation is. If you see, it's till 2023, right from 2006. So this time, if you see the graph, you see that it's always going higher. But predominantly at the end of this course, our expectation is that you get a salary from here. I'll say you might think, oh, how can I get 40,000? I can say I know people after the end of this course would even get something at the range of 65, 70. It depends on how you can actually sell yourself and how you can, your commitment during this internship. So you can see you can get a salary of 40,000 as at 2023, 60,000, 70,000, 80,000. To be honest, there are six figures, way more than this. I know about that too. It's it's just that dedication that can take you this far. So as of this time, this year, this is the salary expectation. And if you can see it, every year is going up. There are new things, new applications coming in. They will always need a tester because if we don't test, the application cannot go live. If there are any mistakes when you go live, you will see the reason. I'm going to explain to you some consequences if proper testing are not done. So these are the salary expectation. So that takes us to what are the good skills of a software tester. So if you're here today, if you've got a good verbal and written communication skill, when I mean that, I don't mean that you should be able to write a pistol. No. What I mean is, can you explain yourself when you see something wrong? What happened? You have used the link, you try to access the link, you're unable to access the link. You just want to reproduce the step by saying, when I was given this link, I put my evidence there. When I click on the link, this is what I'm getting. And you put a picture there. Simple. Once you do that, everyone is able to see that there's an issue here and it will be fixed. You can retest and go back to it. Have you got passion? You must have passion. These are the skills that are needed to be a good software tester. Anything we are doing in life, you must have passion for it. If you don't have passion, there's no need to further continue with it, because if you don't like what you're doing, you will want to get better in what to do. So you need to have passion. Technical skills. What are the technical skills? You are going to learn some technical skills in terms of the automation in this internship. Analytical skills, they go hand in hand. Your attitude, your productivity, all these are what makes good software tester. So that takes us to what are the objectives that we're going to talk about here. So I'm going to talk about what is testing, why is testing necessary, the general principles of testing. Then I'll just give you fundamentals of testing, and I'll give you self-assessment question. Just from what you have learned in the class today, I would like to just for us to just recap on whatever we have done tonight. So that takes us to the first one, testing. Testing. What is testing? This is an activity that is performed to demonstrate that something is working as expected. Let's take an example from what we have stated from our background. If you want to use a pen and you want to sign, and you pick up the pen, you scribble the pen, and it's not working, then you know that you cannot use that pen. But if you scribble the pen and the pen is working, then you'll be able to use this pen. Then, which means the pen is working as expected. That's the major thing we are trying to validate. when it comes to testing. The major thing we are trying to check, validation is mainly checks. The major thing we are trying to check is that a particular system application is working as expected. So when you test the pen and it's not working, then it's not working as expected, because the expectation is that I want to use this pen to write. I have tested it, it's not working. So it's not doing the job that is going to give me. I cannot use it to write. But when I test it and I see that that pen is working, fine, then it's working as expected. So, testing, this is an activity that is performed to demonstrate that something is working as expected. Please, just this is a forever, it's something, as long as you are a software tester, you are any form of tester, this is still the same meaning we look forward to. So now you might ask, is testing for me? You might be thinking, with everything I'm saying, are you sure that is really for me? Okay, let's find out. Let's find out and know whether it's for you or for. Okay. So, who can test? I'm sure you'll be looking. If you see, I took this picture because it's a form in chemistry, physics. This is mainly the way. So I looked at it that that's a good one to say. Who can test? Who exactly can test? Anybody can test. Anyone can test. I've said it. I said, get me room temperature water. Even if you call maybe a little child to say, can you get me water? And you give him the water to taste. Is this cold or hot? He will tell you what it is. And what that child is doing at that time is that he's actually testing the water. So that is a form of testing. So anybody can test. Testing is not rocket science, to be honest. It's not rocket science. So now, what can be tested? Of course, I've been talking about testing. I've been bringing you into it to see what exactly can be tested. I know you might be thinking that the way I'm saying it is it's very easy. Yes, am I saying this way to make it easy? Yes, it is. As long as you follow the process and procedure, to you're going to it's going to be easy. So what can be tested? Hardware, software. What are the hardware? Physical devices, something you can touch and see. Take an example, a laptop. And what else? A software can be tested. So this is something that cannot be touched or seen, e.g., internet browser, the games. So you cannot see the internet browser, but we know it's coming out, is working. You cannot, that's the software, the main software. Those are the things that makes the internet come. The game that you're playing, those are the things that the software, every are the big things inside. So the hardwares are the physical things, things you can touch, that you can see, you can feel, you can touch. Those are the hardware. So how can a software be tested? So if you know, don't forget, this class you are in is manual testing class, is software testing class. So in this phase, it says, what can how can a software be tested? It can be tested manually, meaning you are testing without any tool. Let's take another example. When I mean testing without a tool, you're not using anything. You're only testing from the um, testing the application, doing it manually. It doesn't involve you. It doesn't involve code. Um, it doesn't involve you using any tool to test. It's just design your script, look at it, just the look and feel. Run, run it, check whether this is what is as expected. Take an example. I've scribbled the pen. Is it working as expected? I'm not using any tool. I'm not using anything. I'm just checking it. Those are the things. That's the way manual testing is done. But for automation, but for automation, a tester execute the test case with a tool. So in this course, in this internship, you will be doing your automation testing. There are tools that you're going to use. You're going to use various tools to be able to accomplish the automation part of this software testing side. So, what are some of the tools that you're going to? You will need your Visual Studio. You will need some softwares that you need to add. Talk about your Selenium WebDriver. If it's a web application, you are talking about some of the libraries that you're going to need. All these tools, you can do API testing, which involves Postman. All these are tools that you can use to do to perform automated testing. So, those are the two ways that softwares can be tested: manually, automatically. Manually, without you executing your test cases without any tool. Automatically, you are executing with a tool. Software testing. So, what exactly is software testing? So, this, as I've said initially, this is an activity that is executed to demonstrate that a software, what are the software? Packages, program, systems, product, mobile application, web application, games, just to see that is working as expected. That is the check. That is the validation. That is what you want to see that is working as expected. This word working as expected, even doing automation, doing manual testing, this word working as expected is some of our terminologies that we use when it comes to software testing. So, software testing is an activity that is executed to demonstrate that a software, various things, mobile application system, product is working as expected. So any organization you go to, it depends on the organization that you're working for. It could be a software organization, it can be a financial organization, it could be a tech. It depends on different organization, the tool, the application they're running. That but it's still the same testing process we are going to be using. What's the next thing? Software testing is not complex at all. There are just steps and rules that you can use. It is not difficult to implement, execute, and practice. It is not at all. It is not. So you can see, implement, execute, and practice is not difficult to. There are, because we have procedures, and that procedures must be followed. Any work you're doing, it has to be followed. Then software testing is a discipline. So this word software testing is a discipline, is a job, is a role, is a title, like manual testing, like web application. So it's a discipline. So that takes us to, why do we test? You might be wondering that I've been talking that, oh, why? So why do we exactly, why do we test? So let's take an example again, back to the water that I was talking about. If I said for an adult, it is easier. Maybe if you give me cold water, I can quickly, once I hold the cup or the jug, I would know if it's cold or hot. It's easier for me to feel. That comes again. How do that work? All our senses too, we use it to test. So if you want to eat or do something, some people smell what they want to eat. What you're exactly doing is that you are testing using your sense of smell. Some it could be by touching. You are testing because you are trying to feel what you are doing. It's by sight. All these forms are still under how reason why we test. So why exactly do we test? I've taken a cup of water. I'm making food for a baby. The baby does not know, like a newborn baby. He or she would not know if it's hot or cold. So the risk here now is that if I make hot food for that baby and it takes it into its throat, it could cause various harm. One, it could lead to death. It could cause internal injury. It could even cause a forever injury into the baby. Hence, we need to test. So, for me to make food for a baby, I will need to first check the water, make it warm, check that it's not too hot. If I've made it and it's hot, I'll leave it to cool before I give it to the baby and test it to ensure that is is fine before I give it to the baby. So that takes us to the form of testing. So I'm looking at this, of course. One, we test to avoid software failure. That's a reason. We want to ensure that any software, any application, any system that we are given, we want to avoid failure. Because when it gets out there, thousands of people, millions of people are using the software. We have to be careful. So, talk about if you don't, like we all use social media, various ones. If they are not properly tested, there will be an issue because others could hack accounts. And you might not be able to use a particular social media. And if you know, once you cannot use it, it draws customers away and they go to a better one. So just to avoid software failure, the next thing, a system needs to be adequately tested and the right sort of testing needs to be done as well. So now you might ask me, what is the right source of testing? We are coming to the right source of testing. So that's why I said there are due process and procedures to be followed when we are testing. Now, that takes us to the next thing. What are the consequences? If we do not test properly, what will happen? Loss of money, loss of time, loss of business reputation, injury, and death. Take an example. If you don't test the car properly to see that there is a brake, that the brake is fine, there are airbags, the necessary safety, the seat belt that is needed in the car, and we don't test it properly and someone takes it, one, it could cause injury, it can cause death. Now, if two, three, four people do have gone there and they have the same issue, as you know, bad news spread quickly. Before you know, a lot of people will say, "No, don't go to that organization. You can't buy their car. It's not good because they've got these issues and this." So that's loss of business reputation. Now let's talk about loss of money. After people lose their life, you'll have to pay compensation, even even if it's injury. You'll have to pay. So these are that's why a lot of things have to be done properly to avoid consequences like this. There are a level of risk acceptable for software excuse me, for any software. That is, let's take an example. The way you test an airline application is different from the way you test a financial application. It's different from the way you test an e-commerce application. What are the reasons? The reason is that one is that when you're testing, you want to go for the risk. Which one? So let's take an airline. You want to make sure that the application is tested properly. It could cost loss of life. Talk about financial application, loss of money. If you don't do things properly, m- people could lose their money. E-commerce, some people could shop without paying. So all these things, there are level of risk and levels of testing to be done when it comes to this. So mainly the reason why we test is to avoid failure, is to ensure that all these consequences that we listed here, we ensure we test properly so that these consequences, people we don't get into the consequences. That's the reason of retesting. So that takes us to this next phase of these three brothers. They are they are three in one. So once one happens, it leads to the other one, it leads to the last one. So let's go first for error. Error. What is an error? An error is a mistake which leads to a defect which can cause an observed failure. I said there are three brothers. So the first one will happen, an error. Then it will lead to that error will lead to a defect. That defect will lead to a failure. What does that mean? Is that you have gone into an application, you want to log in, you've put your right details or wrong details, you've just put a details inside and you've put the valid details and you're unable to log in. That's an error. That's a defect. Definitely, because you cannot log in into the application, you can't use it. So it's a failure. So from one to the other, to the other, to the other. So an error leads to defect, which comes as well failure, and the failure lead. So what is error? The error is a human mistake. An error appears not only due to the logical mistake in the code made by the developer, anyone in the team can make mistake during different phase of software. Anybody. So though error is human mistake, you and I could be in the team. So that takes us to, before I continue further, I'll explain how a team runs in the IT sector that you and I are in now. So you as a tester, there are different roles that you work together. You don't work in silo. So you work as part of a team. So it's someone that is going to develop the application you are going to test. So you're not going to be the only person to develop, to test, to gather the requirements, to do the scrum. No. So it's going to be part of a team. Who are those in the team? We've got the business analyst. What is the function of the business analyst? The test cases that we are going to write as testers, there are requirements gathering session that's going to be done by the BA. So the BA product owner, they work hand in hand because mainly the bigger picture of the application you're going to test, the software you're going to do is going to be the knowledge is going to be given to them. What I mean by that is that as a business analyst, as a product owner, they are the ones that will go and get the information from the client. We all cannot go to the client together. So they will get the information, put everything, document it, and bring back the feedback. Now, when they bring it to us, before development can anything can happen. we also need to review it. Do I understand what this person is bringing to us? Will I be able to write something from this? What exactly is this project going to be? What exactly is it going to do? So those questions, we'll talk about them when we when we are in the next class. So we've got the business analyst, as I said, part of the team, business analyst. We've got a product owner, scrum master. That's your like mainly organizing, looking forward to ensure that you all do your tasks and things like that. You and I, we as test analysts, we are here now. And also, we've got sometimes we always have solution architect. So we have people like that. And the main guys there, we've got the developers. So they are the ones going to develop the application. We developers and testers, we work together hand in hand. Though we always have discrepancies, and I'm going to explain to you how it is. But professionally, there are ways we deal with things. So we'll talk about that much when it comes. So those are part of the team. So now, what this statement here is telling us is what is telling us here now is that error is human mistake. Any one of those names, those roles, those activities that I've mentioned, anybody can make a mistake. So that's why it could be done by anyone. So let's go further down. What are examples of errors? Examples, it could be from the business analyst, as I said. Maybe the business analyst misinterpreted what the client or misunderstood the requirement. Again, it could be the customer. Maybe they have there might be insufficient information, or they are not sure of a particular thing. They don't know how it's going to work. Then the other thing, we've got the architect. So it could be in the flow, it could be in the diagram, it could be in the solution diagram. It could be that. Then we've got other people like you and I. We and some it could be due to tiredness, some could be sick, and maybe just make some mistakes. So all these are various examples of error. So that takes us to the next one, defect. Who exactly is this defect guy? What does it do? So, defect, I put it here to say that it's a warning. It's a warning to let you know that defect, defect. So, defect is inconsistency between expected and actual results. Now, throughout my lecture, I'm going to be giving you twins, two words. They are always together, they work hand in hand. So most of the time, when they ask you in an interview, if they ask you for one, they will definitely ask you for both. They always ask for both together. And throughout, you are doing manual, you are doing automation, anything testing, expected and actual results is a normal terminology. If you say it to a business analyst, he or she understands. You say to a product owner, to a project manager, to a solution architect, talk about anybody. In fact, any layman, they know that expected, actual. So these two words, I want you to keep it. Write it down. I'm going to ask you the meaning of those words. Sometimes these are interview questions. Expected and actual results. So, expected. What is your expectation? That's what we put down. So now let's take example of the pen. Your expectation is when you pick up that pen in the requirement, it says when you pick up that pen to write, when you scribble it, there should be ink and it should write. That is the expectation. So that's the expectation. Now, The other thing is actual. What is actual? What is actual? Now, you've been given you've been given the you've been given the pen. You've tried to scribble the pen. Your actual now is that you are using that pen exactly. You are using it now. And what I am saying now is that the pen is not working because you are using it. So your actual is that you are saying it now. I'm using it. Your expectation is what you derived from the requirement, what you are expecting. And what you were expecting is for the pen to write. But now in your actual, your real world, when you are trying the pen is not writing. Now the question to you is that what does it mean? Is it working as expected? No, it's not working as expected because you're seeing it now, it's not working as expected. So remember, expected and actual result. When we are designing our scripts, expected actual result will always be there. There are key fields that has to be there. So, what is a defect? A defect is in a software product reflects the inability of the software to comply with the specified requirements. Subsequently, prevent the software application from performing the expected work. So, the application we are working on now is the pen writing application. That our pen, if it's not working, if it's not performing as it's meant to perform, then we raise it as a defect. So if it's not performing as it's meant to be, then it's a defect. But if it's performing as it's meant to be, it is not a defect. Correct? So if it's not performing as it's meant to be, it's a defect. That is the reason we have that one, because it says the application from performing the expected work. So it should work as expected. So defect can also be called an error that the tester finds is known as defect. So when you find an error, we call it a defect. Defect have other names. Some call it bug, some call it fault, some call it failure. So it's different things you can that we call it. But most of the time, we call it either a bug or a defect. So an error that a tester finds is known as defect. The defect is also known as fault. So that takes us to the other bit of it, which is failure. What is failure? Failure is a consequences of a defect. So you found a defect. Definitely is leading to um we found a failure. If you find a defect, then definitely it's a failure. You can't continue. I gave you an example. You try to log in, you cannot log in. What does that mean? You've done everything. You use the valid account. You've done it. So if you cannot log in, then it means you cannot. It is a failure. You cannot use the application. So you raise the defect. It is the observable incorrect behavior of the system. Failure occurs when the software fails to perform in the real environment. So, we have given you the environment to test on. You've tried to test to log in. Unfortunately, you're unable to. So, if it doesn't work in that real environment they've given you, then it's a failure. In other words, after the creation and execution of software codes, if the system does not perform as expected, due to the occurrence of any defect, then it is termed as failure. Failure. So not all defects can be found. These are mainly in the code. So you could be inactive in the code. You could leave it, refactorize all the time. Developers do that. So that is for the three that I've said: error, defect, failure. Error is human mistake. Error leads to defect. Defect leads to failure. So that takes us about keeping software under control. So it takes us to these four key points. Exhaustive testing of complex system is not possible. What do we mean by this? If you've got a complex system, there are big applications that is you can't. That's why I said there are procedures and processes to test. So when we design our scripts, when you're given an application, you finish designing your script, and the application has been developed, given to you as a tester, and you've got maybe a lot of script to execute. The first thing we need to do is you need to prioritize. How do you prioritize? You need to look first. What are the risks? We are going to talk about that. What are the things that, if you don't test it properly, you cannot, there could be there could be consequences if they are not tested properly. That is why it goes to why do we test? So those priorities, when you prioritize, those ones are the ones we test first. Then we might have some the minor ones. It's nice, of course, you can test it, maybe, but if you don't have the time, if you are to hit a deadline, then you need to test. You need to test systematically. And we are going to, I'm going to explain to you what I mean by that. So, exhaustive testing of complex system is not possible. Let me bring it more simpler for you. Let's take an example. Let's take an example of cars here. If you are given an application, a car, let's say in the UK, cars come twice in a year. We've got one that will come like in March. That's the first one. Then the second one will come at the end of the year, like September. Now, the question to you is that maybe you were given an application to test in 2021 for the 2021 model of that car in March. You've tested, and you've tested. You want to make sure, oh no, I'm not impressed. You waited, you've tested till September. September, the other brand of car needs to come out in September. Now, we have not finished testing in March. September cannot come out because we've not sold the one in March. Now, the one in March is still there. We've not tested. The one in September is waiting for the one in March. We have waited again 2021. We've moved to 2022. You've not finished. Oh, there are still bugs. I'm testing. 2022 March. So now we have three waits. 2022 September. That's four. What happens is that they've lost a lot of people that booked for the cars. You have not finished testing. So when exactly are you going to finish testing? Is it in 10 years? When the car is out of date? So those are the reason why we say exhaustive testing of complex system is not possible. This time around, you need to systematically prioritize what you want to do. What are the risks? You need to look the brake, the check the components that you know that are risk to to the car, that you test them vigorously. Those are the first thing to do to ensure that you prioritize. Now, it takes us to this. It says testing had been run. Testing would go on for a long time and product may never get into the market. That's the example of what I gave you. If you continue running, we might not end up in 10 years' time. That car might not come. So everything will just be stocked there. How will you make money? How will salaries be paid? So those are the things that we need to think of. It is possible to run every possible test, simple and it is simple or complex system. With large and complex system, it will never be possible to test everything exhaustively. In fact, it is impossible. I will tell you, it's impossible. For simple system, let's take an example. What do I mean by simple system? The pen system that we are talking about. I've given you a pen. The only thing you need to do is to scribble, check everything. Is there ink? Can I write with it? Those are easy. You know the application, you know everything in and out. It's very easy. So you can test and know that yes, that pen is working. When the ink is in the pen, it can work. But it will not work for some application. Is it the financial application? The e-commerce, that you have various components, various navigations to test. So you need to know the ones you need to prioritize. The key thing here I want you to understand is that you need to prioritize when you're testing. Go for the risk first. When you're doing the risk, think about the quality. When you're talking about the quality, then it will make you know what we are delivering. Is it the right product? Is that it? Those are the questions you ask yourself when you are testing. Always remember, you as a tester, you are the one that is going to put your name on every sign off to say you have finished testing. Now, you and I know if you don't test, if you put your name to say, you know, you're not confident with what has been tested, you know, there are still bugs, and you put your name there. When things happen in production, you'll be fired. So, the first thing you want to be sure is that have you done the right testing? Before I rubber stamp my name on anything, I want to be sure that I understand and I've raised every concern. When you raise your concern, this is not working, this is not working. If they choose to put it forward, you would have put it in your own report. This is not working, this is not working. I'm not happy to sign off. The project manager can take the lead to sign off. The product owner can take the lead to sign off. That's fine. Let them sign off. If anything happens in production, your name is not there again. So whosoever has signed off will face the consequences. So those are the procedures to use. So that takes us to when is testing enough. I've been saying you'll be wondering that how do I know? I've used prioritizing. So I start with the risk first, test all the risk, move to the medium one, then move to the minor ones. That's the way if there is time, because there are time limits, there are deadlines that will meet. You might be given an application within 2 weeks, they need you to deliver. So you need to be to test properly. Some might even come within 3 days. Can you deliver? So you have to. So when you have tight deadlines like that, be careful and organize yourself by prioritizing. When is it enough to, when is testing enough? That takes us to these three main things. How do you know that I can stop testing? So use these two words. When you're testing, the first thing when you're testing, be checking the risk. Test and risk. So as you're testing, check which ones are the risk. Take the car, for example. What are the risks in the car? Start popping it in the chart. When the risk, what are the risks when you're testing a car? What are the first things should we check? Let me go into the chart. Just pop it in the chart, please. What do you think So pop it in the chat. I've not seen anyone. How can we get tools needed for automation? So I'll come to your questions, everyone. So what if you're testing a car? What are the main three? Fantastic. Well done, Peju. Oh, yeah. So you put the brake. Fantastic. What else do you think we are meant to check? What else do you think we are meant to check? Make sure the car doesn't leak. Correct. Fantastic, Alex. What else? He said brake. They've looked at the leaking fuel. There are some other components, guys. Water. Yes, but we're still getting there. Be, there's a major thing. Tires. Fantastic. There's still a major thing I'm expecting. Someone has not. Let me see new messages. Fantastic. Who said engine? Engine. Fantastic. Yes, guys. Well done. Is this Ianu also? Doors, fantastic. Good point. Good point. Steering wheel, correct. All these are components that are expected. So when we are testing, so those are the risk that you are going to look first. Now, someone might ask, can I ask you the color to the car? It's not really a risk, it's still minor. Maybe you wanted blue, they've got sky blue. We can come back to that at the later on. That's just to paint the car. But the main thing here are the least things that you all have mentioned there. You've talked about engine, you've talked about brake tires, water, fuel, dangerous. Doors, we've talked about the steering wheel. These are the key things that we have to look at. And as you're testing also, we need to look at testing and quality. What When you're testing, you have to check the quality. Is the quality we are producing, is that the right quality? Is this good quality? You have to check that. Then you cannot decide that enough is enough. Well, let's manage it. We have checked the engine, we've checked the brake, everything is fine. We've gone, that is it. So that's the key thing. Then we can say it's enough. Let's be going. We'll still be testing. It's testing in progress. It's just like different um various version of phone will come out. One we might have 13. The next thing before the next year 14 will come out. They'll put this feature. The next one is 15. So it's a lot of various version will be coming out. So if we stick to one, we won't be able to move on. So those are the ways that you can decide that enough is enough for testing. That takes us to general principles of testing. What are the general principles of testing? We have 7 of them. Always have it at the back of your mind. We have 7 of them. General principles of testing. 7. The first one is that testing shows the presence of bug. Correct? Yes or no? That's the reason we are testing. It shows the presence of bug. Exhaustive testing is impossible. That's what I've told you initially. Before now, keeping software under control. So exhaustive testing is impossible. You can't vouch that I have finished testing. It's bug free. It's impossible. It is impossible. You cannot say, oh, this system now, there's no bug there. It's impossible. If it's no, it's impossible. So you can just say you have executed the risk, you have done main things. That's the way you prioritize and you do. Early testing, what does this mean? So from every phase, in terms of requirement gathering, from when the business analyst send you the requirement, you start testing from there. Start reading through it. Do I understand it? This ambiguous word here, what does it mean? Break it down. Let's know what it is. So early testing, when you test early, it shows the presence of bug. So if there's bug in the requirement gathering, in the requirement that have been given to us, it will be fixed quickly. And what is the advantage there? Before it gets to the developer to start developing, it won't have gone further. It's just minimal. Change it by in your on your computer by just typing the word and making it simpler. So it's easier. Someone can change it. Than when it's gone into the software, code has been written, time, resources, everything have been used. So we need to be careful. Defect clustering. What does that mean? Defect clustering, where defects are packed, where they are clustered. Those are the general principles of testing. Then we've got pesticide paradox. What does this mean? It doesn't mean because you've run um, a set of tests severally. When you run it severally, the same test, you end up not finding anything in the you might end up not finding any bug. Let's take an example. If I'm given a page that is full of error, a chapter of a textbook to read or a storybook, and I'm meant to look for the bugs there. When I start reading that chapter one after the other, by the time I start, I might get a lot of bug, like 20 bucks. Fix this, change the content, change the type. You didn't there are various error spellings, different things. I'm still the one testing it. Now, that's the first time. The second time, when I read the same, when I go through that test again, you check, I might find few errors. When I go through it again the third time, now I'm getting used to the book. I'm getting used to that chapter. I may end up not finding anything. If I go through it the fourth, the fifth, the sixth time, nothing will, I would not find any error again. Why? Because I'm doing the same thing. I'm looking at the same eye. That's what I'm using to check. So I might not see any error there again. Take the same thing that I have found error. Let me give it to another tester, like Rose. Let me give it to Rose. She would pick it up and she would start checking. By the time she starts checking, Rose will find a lot. Oh, you made a mistake here. THE. It should, I mean, it's meant to be D and it's TEH. So that's a correction because she is coming from another angle. She's looking at it. Maybe she too, Rose has gone through this same rigor, checked again. If she gives it to another person, we, the third person can also get get other bugs. So what I'm insinuating or saying about pesticide paradox is not because I've executed this test 7 times, 10 times, it means it's error free. No, it doesn't matter because I'm still running the same test. So that's why a third eye will kind of good. Then the other one, the sixth one is testing is context dependent. Do you agree with me? So what I mean is that for you to test, you need to put something in to test. I've been talking about testing. How do I test? I said, give me room temperature water. What do I need? So I need water. So I need water, I need a cup, I need those instruments. So that's when I can get the room temperature water. I need cold, warm water. That's that's the way to. So you must put something in to be able to test. That's why it says testing is context dependent. You want to log in, you need to log in with your username and password. Those are context. So to say. So absence of error fallacy. So you saying there is no error, it's a fallacy. You cannot vouch to say there's no error. Can you vouch to say that when someone carries that car and is running at 200 miles per hour and is overspeeding, anything could happen. So you can't vouch for that. So those are things that so general principles of testing. These are principles of testing. Please pop in your question on the chat. So before I go further, let us look at let me go first to some of the question. Any question that you have, I'll just so we've just got two questions. Are we going to learn about SQL? Yes, they are going to teach you the basics of it to use the select command and how to query a database. Yes, you're going to learn about that. Then how can we get tools needed to for automation? Great question too. So for automation, in the automation class, you will be given, um, you'll be told what to use, the set of tools to use. So what I mean is that um, you will be given a list of tools to be downloaded. So mainly the tools are things that you're going to use on your laptops. So they're like Visual Studio. It depends. It could be the latest one. Then you are going to download it. They will tell you how to download it. You will have the process. That someone we've got tutors that is going to run you step by step. Any issues you find there, you will be there will be mentors, bodies, people. We have a great team to get you all on board and make sure you can do. So make use of the opportunity. As I've said, anything you are taught here, please don't don't leave it. Follow the class. When the class is on, make sure you are doing the right thing at the right time. If you store it to say, I'll watch the video later, I will do this, it accumulates. So try and follow it. That's the best way. Any other question? Let me see. So in the absence of none, I will continue. So these are the 7 principles of testing. So that takes us to fundamental test process. What is a fundamental test process? I've said so much about. Now I want us to talk about the process. Look, all these principles that I'm telling you, all these words that I've been saying right from the beginning, this is what I'm going to say throughout we finish this course. Everything I've been saying today, you would it today is mainly like scratching the floor, telling you like someone looking for something. I'm only bringing you into manual testing for you to understand. Nothing is going to change. Everything I've said is still what I'm going to continue with. These processes, these methods, everything I've been saying, you will find it more useful when we go in depth into the class. By the next class, the third class, you'll see everything that I've said in action by then. So, fundamental test process. What is this process all about? So it takes us to I love to use this example because this example is it will give you a clear picture. So when I'm teaching, I always like to go outside world, then come back to what we are doing in IT. So let's take it to we can see you can see around people building houses, even the government building various houses. Now, the question is that before you can erect a building or build a house, there are procedures that you need before a house can be built. Can before we continue, let me go to the chat. Let's just brainstorm together and let me see your idea on it. Since we have to prioritize, so before we go further, okay, since we have to prioritize our testing by risk and quality, how can we tell from the requirement what is important? Correct. So, fantastic question, Rose. So, what from your requirement? In the requirement, there are things that there is a field that will tell you it's mandatory, it's compulsory, it's a must have, should have. So if I tell you it is a must, you must have it. What it means is it's compulsory, it's a priority. From the requirement, if it's a mandatory field, if it's mandatory, you must. It's part of your requirement, it's part of the things that you need to test. So from the requirement, that is how you can determine that this is that. So that's how you can determine that this that this is. It is this is how you can determine how to prioritize your test cases. So I hope I've answered that. Well, you'll still all answer. We'll talk very soon. I'm going to finish in a bit, but let's go further. Before we continue, I was talking about a house. So we want to build houses in the people are building houses, the government are building houses, but there are things that they do before they can erect that building. Because if you just erect a building on just a land without doing anything, that building could collapse. So the first thing I want to ask you all, what do you think are the things, just pop it in the chat, that you think that are needed when you want to build, when you want to build a house, a normal house, a house, a flat, anything. What do you think? Let's pop it in. Yes, I can see people going in. Adegboiga. Approval to the building, fantastic. Um, Alex, okay. Plan, fantastic. Those are words that I want to hear. Correct. What else do you think? Planning, yes. Thank you. Merci, yes. Planning. I'm waiting to see more. Materials, correct. E.g. blocks, correct. Absolutely. Absolutely. So, right tools. Please, can we have the trainer screen? Sorry, Esther, I don't understand. When you mean the train, do you mean you want to see my screen?
Yes, it's only Rose's screen that we are seeing. We can't see your screen here, please.
Yeah, because I'm not sharing my screen. I'm looking at the chat.
Okay, thank you.
Yes.
Okay,
I'm looking at the chat. So I'm looking at your answers. Before I continue, that's what all this point is what we want to use in the next one. So, right tools, correct. Fantastic. Who brought this again? Design. I think Adura Gbemi. Fantastic. Structural design. Requirement for the building. Fantastic. Building contractors. Great. The land to build on. Fantastic, everyone. These are the things that we need to build. Now let's bring it to software world. So there are 5 processes. 5. Let's start. It is one at a time. So the first one is test planning and control. Please mute, please. So test planning and control. The test planning and control here. Someone in your chat, a lot of people mentioned planning. That is the first phase. You've all mentioned everything that we need here: the materials, the tools, the land, the approval, everything you've mentioned are correct. So that brings us, we want to group them into these 5 phases. So test planning and control. So for a builder, they will need to plan. So when you need to plan, while you're planning, you are doing the approval of the building of to build. So all these things are all coming together as one. Let's bring it back to our own world. So when we too want to work as testers, the first thing we need to do is to plan. Test plan. They have said that you are going to work on project Yemi or project Pen. The first thing you want to do is to start planning. What are the plans? Start by designing your start getting familiar, understanding your test plan should be here now. So as you're planning, you are putting everything, controlling it. Oh, this is what is going to happen. This is it. So your plans are the first phase. Then the next thing that goes, always remember, test planning and control is 2 words. You are planning, you are controlling it. You are planning, you are checking, you are planning, you are checking. So those are you're putting everything under control. Then the next thing you do is test analysis and design. Someone said design. over there. So you said design, you said building materials, you've mentioned some other things in your when we were when you put everything in the chart. So this comes to your second level. Now we want to analyze and design. So what is the analysis now? Is that we want to start from the requirement that we have gotten. We want to start. Oh, what is the thing that we what is required? We'll start designing our script. From there, we analyze what are the things that we want to, what are the scenarios that we're going to do. Then we'll start analyzing it, we'll start designing. So, some people, you might ask me that why the word design? Design is just like writing, writing. But you know, when you're doing a job, you want to make it look professional, sound different. I won't want to be using the word check. I'll be using validation. It makes it looks difficult so that people will know that yes, the job I'm doing, I know what I'm doing. So that's why we use those big words. So instead of it to say I'm writing my test plan, I know you are going to type it. I know you are going to type it on the system, but don't use the word writing. Design. Design. Don't I'm not writing. I am designing. I know you're writing it, but you're designing. So you say, I'm designing my test script. I'm designing my test plan. So they know you're writing it. So that's the next analysis and design. So after we have done that, then we've got a third phase, which is test implementation and execution. What is this about? In the analysis and the design, you would have looked at it, you have written script. Before I go to the third one, I'll go back to the second one. Please, and please, this what I'm going to say now, note it. Anything you are doing in testing, I keep telling you that whatever I'm saying now is going to be used all through your testing career. That's why I'm saying it, all through your testing career. So when you're analyzing and you're designing, there are phases. You might write scripts that is, let's take an example. Five test cases is what you have written as part of when you are designing and you're analyzing. These are the things that you have done. Five test cases. Just hold it like that for number two. Number three, test implementation and execution. Implement, execution. Implement, execute. What does it mean to implement? I want to start building it. Someone said, start buying blocks. This is where we need the blocks. We want to implement it. So now, our own test cases, we want to start using those test cases now. We need to implement it. We need to put it, start executing it. So once you are implementing that test case you are writing, you are executing it. What is execution? You are testing it. So I've written five test cases. I have run the five test cases. Three of them pass. Two of them failed. In our career, we don't go with numbers, we go with percentage. Even when you are given statistics in most of the time, everything that you see on the news is always in percentage. You see statistics 0 point this, no, you see 66% of this, 50% of this, 70. So we also use percentage. When your manager comes to you and say, Yemi, how many test cases passed? Analyze it. You'll say 60% passed, 40%, 20 failed, 20 is blocked, or you are unable to run it, or 60 passed, 40 failed. Whatever has happened, you just need to read. You can see I've used five. So in a nutshell, what I mean is that if it's 10 test cases now, I'm going back to the class. If it's 10 test cases now and 4 passed, 4 failed, 2 blocked, give me the percentage. First person gets a lolly. First person gets a lolly. 4 passed, 4 passed, 4 failed, 20 blocked. Give me the analysis. On the chat, I'm waiting. Oh, 10 test cases. 4 passed, 4 failed, 2 blocked. Fantastic, Alex. 40% failed, 40% passed, 20 blocked. Fantastic. Fantastic. Alex, you get 5 lollies. So that's 40%, 50%. So understood that way. So anytime you're doing it, even if you cannot, just look at it, calculate it with. It's not, we don't need make sure it's near accurate. You could use your calculator if you can't, and that. So test implementation and execution. Say, for example, you have put 5 test cases. It's been implemented. That's what it means about design. You've implemented it. Now you want to execute it. So the first one says login. What are you logging into? By the time you are going into the application, you click on the link, you put the username, you put the password. You are executing it. So the two of them work hand in hand. Test planning and control, they work hand in hand. Analysis and design, they work hand in hand. Implementation and execution work hand in hand. That takes us to the fourth one, evaluating exit criteria and reporting. Another twin in this class. I gave you the first one. What's the first twin that I gave you? Someone should put it on the chat. What's the first 2 words that I gave you that you must keep? I said all through my class, I'll be giving you two words. 2 words that they will be the same, they'll be twin. I've said it. Let me see what. Fantastic, fantastic, fantastic. Exam, yeah, yes, expected and actual result. So yes, thank you, Alex, Rose, Aduragbemi. Thank you, guys. You got the word. Now that takes us to another 2 words: exit criteria and entry criteria. Exit criteria and entry criteria. Entry is ENTRY. Entry. So what does it mean? Entry. I want to enter. I want to start. I want to start testing. That is entry criteria. Interview word. Interview question. What is the difference between what is entry and exit criteria? Most of the time, these 2 words, people mix a lot of the 2 words I'm going to be giving you. So, entry and exit criteria. When we are doing test planning, when we are doing tests, when we are designing, when I'm teaching you how to write a test plan, I'm going to be using this word. All through, I'm going to be using all these words I'm mentioning to you. So, exit criteria and entry criteria. So, entry, I am starting. Start testing. You want to enter. I want to enter into testing. I want to start testing. That's what it means. Exit that door. When there's a fire outbreak, use the exit. So that exit, go out, stop. That's what exit means. Stop. So the 2 words, again, I'll give you entry and exit criteria. So number 4 says evaluating exit criteria and reporting. So what it means is that you have finished implementation and execution. Analyze it. So Alex brought it and said 40% passed, 40% failed, and 20 blocked. That's what he gave us as the analysis. So That's what I analyze and I will report against. So as you have stopped testing, you need to give a reporting. So two of them have to work together. And the final bit of it is test closure activity. What is test closure? Now we are finished. Maybe the bugs have been fixed. They've given it back to Alex. Alex, can you retest? He's retested it. Everything is working as expected. The failed ones work, but we've still got some blocked ones. Okay. Are you happy, Alex? Um, I'm not happy because these two are critical bugs. Unfortunately, we can't go. Okay, let's fix the critical bug. You fix it. Are you happy? Because you as a tester, you are determinant to any testing done. You are the one to sign off. You are the one that will say you are happy. If you want to hold them down and you want to test, you're fine. If you're not convinced that that thing is working, make it known. I'm not convinced that it's working. And tell them what is your reason that it's not working, because this and this is not working. I have tried to log in. This thing is crashing intermittently. So predominantly, if I do it here, it's going to happen in the user's environment. It's going to happen in prod. Let's fix it here. I'm not happy to move it. Everyone will look into the issue and they will try and see it and fix it. If it cannot be fixed, it is non-bug. Are they happy to leave it? Yes. As the program, the project manager signed it off, yes, he's happy. But if you feel you've done everything is fine, you've all the things you prioritize have been run, you're on a good phase, you feel that things are coming to shape, that's fine. Then you put it, then you create a test closure report. It's called a TCR, test closure report. What does it entail? Just analysis of what you have done. You put everything in the report. Whatever you find, oh, we've got two bugs outstanding. There are critical bugs, this and this and that. This is the mitigation plan. This is what are mitigation plans. Those bugs, where are they? They are currently being fixed by the developer. You put those things there. They are currently under investigation. Those are the few points that we need to put there. So that ends the whole process. Remember, general principles of testing, we have 7 of them. Fundamental test process, we have 5 of them. Test planning and control, test analysis and design, test implementation and execution, evaluating exit criteria, test closure report. And this takes us to the psychology of testing, mainly a summary of what we have done. A variety of different people may be involved in the total testing effort, and they may be drawn from a broad set of background. It could be from the developers, professional testers like you and I, specialists. So I might be good, you might be good in testing very well. There might be someone that knows the application in and out. We can drag him into it so that everything, I know I've run it. That's where pesticide paradox comes in. I've done my own testing. He is a specialist in it. It comes into it. Take an example. If you go to doctors, if you go to the hospital, a doctor must have seen you. He will tell you, no, I also want to make a check from my senior consultant. That is a specialist. He's a doctor. The other person also is a doctor, but I still need someone to affirm, to help me test, have a third eye, have a look at it. So that's it. Such as those with performance testing skill can bring performance testers in, while others are drafted to assist with acceptance testing. That takes us to the end of the class, please. And I'll say thank you to all of you for this night. And I'll put it as my Q&A session. Now, you are free to ask me any question and I will answer you. At this phase, you can unmute and ask me a question if you want to, but just raise your hand and I will call you one after the other. First,
sorry, Yemi, please, do I stop recording here and then do Q&A separate?
You can leave it.
Okay.
You can leave it. What is the difference between reporting exit criteria, and test closure report. Okay. Exit criteria. You want to tell them that you are finished. Okay. You want to say you finished. You finished, and this is what the outcome is. That's it. So from your stopping, you have stopped testing. When you stop testing, you need to give us in a report to tell us that this is what you have tested. What I mean is 10 of the bugs were done. This is what it has been done. Just give us an explanation of what you have stopped testing. That is it. Just analyze what you have done from 1, 2, 3, 3. Give us the analysis. Now, test closure report. It says, I want to sign off. I am signing off. So you want to give us everything you have done. What you have done in evaluating your exit criteria goes into your test closure report. Now, any doubts, anything that you see that you have not done, you put it there. So your test closure is a full package of an end-to-end that this is the testing carried out. This is what you are. I am happy to sign off. That is where you are going to put it in your test closure report. Is a decision time. To say you are happy to sign off. I am not happy to sign off, except, or I'm happy to sign up if this is going to be fixed or carried to UAT. You will set your caveat there. If you're happy to sign off after the bugs have been retested, you write everything there. With a 5-3 page, all the bugs that you have raised, you can put it on a sheet and let us know that these are the bugs that have been raised. You can put the open bugs also on the sheet to let us know. You can have any defect density graph if you want to add it to it. Those are what entails in the test closure report. So what the difference is that when you stop testing, you are not giving us a full package. You're only telling us that I've stopped testing and this is the report, this is what we have done. But in the TCR, is a final sign-off. That's the difference. So before we finish the class, I'm going to ask my question. There's no how. So this is my self-assessment part. So the first question I'm going to ask is that how can testing be done? If you know the answer, just tell me. If you want me to give you lollies, I give a lot of lollies, candies in the class. How can testing be done? It's taking time. Let me see. I'm looking. How can testing be done? Now you can unmute yourself. Fantastic. Manual and automation. What can be tested? What can be tested? Raise your hand. I want to make sure that everyone is following me. What can be tested? No, if you've answered, I'm not going to allow you to answer. Raju, or what is it? Yes.
Yeah. Good evening, everyone.
Good evening.
Hardware and software.
Correct. Hardware and software. So someone else should pick it up. So you can put your hand down. So what's the next person should pick it up? What is hardware? What is software? Who is going to help us? What is hardware? What is software? What is hardware? What is software? Unmute yourself and talk. Who is talking? No, Iyanu. Iyanu, can you move?
Yeah, good. Thank you. Hardware are those things that can be seen and touched, while software are those that can't be touched, but they can be seen.
Correct. Correct. Well done. Well done. So, Rose, you have another 2 lollies. Iyanu, you have 4 lollies. Reju, you have 4 lollies. Well done. Well done. I'm going to put all the lollies in the chat for you. Don't worry. Everybody with ice cream, I'll send everything to you. So the next thing is, what is error? What is error? Oh. Alex. We can't hear you, Alex.
Oh, sorry. Error is a human mistake that can lead to a defect.
Mhm. Correct. Fantastic. You've got 4 lollies. So who else? I'm going to call names because I want to make sure everyone in the class has. If you have any question, you are free to unmute and ask me. But before you ask me, I need to ask you my question. So, what is defect? What is defect? Okay. I'm still seeing just Alex. What is defect? Should I call names? Alex, go for it. Alex, go for it. Alex, we can't hear you.
Sorry, I wasn't raising my hand though. That was a mistake.
Okay. Sorry.
Turn it up or set volume to level 5.
So, defect. Who is going for defect, please?
I'm going
Mercy.
yeah.
Well done. Yes, go for it.
A defect is an inconsistent between an actual result.
Between, you've not finished it. Between
Actual results.
inconsistency between expected
And actual
and
results. Yeah.
fantastic. That's what. So you get 4 lollies. Mercy, well done. Well done. The girls are winning. Oh, the guys, please go for it. So the final, what is failure? Failure. Who is going for failure? Fantastic, Mohammed. Yeah, you said it's a fault or a bug. Yeah, but we just need to know the exact meaning. Yeah, those are the names that it could be called. Well done. Who is going for failure?
I can go.
Well done, Alex. Go for it.
So the failure is the observable incorrect behavior of in the system and is caused by the defect.
Correct. Well done. Well done, guys. So 2 more questions before I give you time. So the next one is, how many general principles of testing do we have? If you've answered no, if you've not answered, please. I will call names now. If you know
Yeah,
you've not talked.
let me come in.
Ayo, yeah.
Yes, we have 7 principles of testing.
Can you give us one starting?
Yeah, testing shows the presence of bugs or defects.
Fantastic. Well done. Fantastic for lollies. Well done. Next person. The second one. If you know, you just unmute and say it. Second one, Ayo, go for it again.
All right, exhaustive testing is impossible.
Fantastic. Well done. Third one, you have to stop.
Testing. Easy testing.
No, early testing, Mercy.
Early testing, yeah.
Fantastic. Then the fourth one.
Defect clustering.
Fantastic, Alex. Guys, take 2 more. 2 lollies. Number 5. I've just said that one here now.
Pesticide paradox.
Pesticide paradox.
Fantastic, Rose. Take 2. 6th one.
Absence of error fallacy.
Nope.
That's the 7th one, Ayo. The 6th one.
Testing is
Testing is context dependent.
Context dependence. Fantastic. So the 7th one is Absence of error fallacy. Well done. Well done, every one of you. Well done. So the last one is fundamental test process. How many do we have? Is it 8 or 10? Fundamental test process.
We have 5.
5.
Is it 5 or 10?
5.
5.
No, check properly. Oh, is it okay? It's 5.
5.
Oh, okay, correct. It's 5.
5.
So what's the first one?
Testing and planning.
Test planning and control.
Planning.
Correct. Second one,
Test
Test
analysis.
Analysis and design.
correct. Third one,
Test
Test
implementation and
implementation and execution.
implementation.
correct. Fourth one,
Evaluating the
Evaluation
criteria and
criteria
reporting.
Experience and
reporting.
reporting.
fantastic. Then the last one.
Test closure
Test
activity.
closure
activity.
activity.
To be honest, I give everybody lolly. Every one of you did fantastic work.
I won't
So-
collect lolly too.
Adura Gbemi, yeah, fantastic. So you get 4. In fact, your own is 5 now.
Thank you.
So you all did fantastic. So in our next class, everything we have said, we are going to work towards it. Just go briefly with it. This is just the easy part of it. At the end of this course, my expectation is more of a 6 class, 6 lectures. We should be fine. By the 4th time, you should be writing your script. So when you're writing your script, that's the major thing. We have come here, and I'll tell you how to look for a bug. You can start looking for your role. To be just diligent, please. Don't store anything. Don't keep anything to the last end, please. Do it. So, oh, fantastic. I'm giving everybody the lollies. Don't worry. So now, any questions?
Yes.
Please.
Okay, so my
go for it.
question is, can I go?
Yes, please. Go for
Okay,
it.
so in testing, in manual testing, software testing, we hear about validation and verification. Can you just expatiate about the difference between
I won't do
validation
it.
and
I won't do it today
right?
because
Okay.
it's in my next class.
All right.
So
that's fine.
that's why it's always a process. That's why I said today I've already moved it. In my next class, it's going to be what is going to be part of the topic.
Okay. Secondly, you mentioned that manual testing does not involve using of tools to execute it.
Correct.
But
Correct.
when I've been watching some videos, I've seen APIs being used, Postman being used for manual testing. So how does that come
Yes.
to play?
So in that phase, what you are doing with the API, you are manually testing it. Correct. So the tools that we are talking about is mainly codes. Using automation are part of it. But there are ways you can do test manually. You can manually test a code by reviewing it. You are not running it. So you might have seen API being used using Postman. Excuse me. So
Bless you.
yeah, thank you. So you would have seen API and Postman being used, but they are being done manually. Postman is broad. You can automate it. You can get your codes from there when you want to do Postman. So what you're saying in terms of tools is we are not running it automatedly. We are not leaving it to do, you are not coding to do it. You are using your hand to do it. That's what it means.
Okay, thank you.
Any other question? Please, in the class, you are free to ask any question.
Okay.
Any question? There's nothing silly. There's nothing. I'm here to help. We are all here to help. Please, go for it, Alex.
All right. Earlier, I think Rose asked a question about prioritizing tests by risk and quality. So I asked in the chat earlier, because we watched a demo, and during the demo there was a section in the demo when the Scrum Master was asking the QA to rate a ticket or or a PBI or something of that nature. And so the tester was saying, you know, she gave it a 3, or she gave it, they were using what's this thing called again? I don't know what it's called, but you know what it's called.
Fibonacci,
Yes, Fibonacci's
Fibonacci or something like that.
yeah. So
Correct.
my question is the prioritizing of a PBI done only in sprint planning, or is it done separately by a tester?
So it's done both in sprint planning by every one of us. Let me the reason why you're very right, where when you said the person gave it a 3. The first thing is for you to understand the concept of how you use your numbers when you are given to when you're planning. You need to be very careful. The trick about it is that when developers go for their own first, use a yardstick of whatever developers use. But you can make yours either a bit bigger or the same rate. I'll tell you the reason. I'm just telling a trick about it. Is that when you are told to plan, take an example, login. You have written maybe you can, in a login scenario, you can write 20 test scripts, 20 test cases. If you write test cases of 20 and you've given it 3 or you've given it 1, are you sure you can execute it within a specified time or the deadline? No. So when you are looking at a story, think about it. What I'm testing, how big is this? What are the points that the developers have raised? Because you have to validate against whatever the developers have done. That's the essence of it. So is either you are rating yours higher. So it's not just coming and bringing a 3. It might not be a 3. It might be, it could be a 5. It could be a 1. It could be an 8. So it depends. At that phase, when you're given a story, when you've read, before you go for your planning, you can ask, because you have just started, you can look at the story. You would have had the story that you're going to look at if you've given beforehand. If not, if you're there, your mentor or someone should be able to put you through. When you look at the story, the first thing I want you to think of is that, how long, what is this story about? If you're taking a login scenario, there are many possibilities. You are doing both positive and negative scenario. So you have to take your time to test it. There are certain validations to be done there. So you have to take your time. A 3 might not be enough. You could put a 5. The reason for you to, because when you put a point, you need to be able to justify the point. How do you justify your point? To justify your point in this case, you say, oh, I have put this number because I've got XYZ scenario, this and this and that. The developer has done this, I need to validate against it. So those are the points that you need to bring out. So don't just put a 3. In terms of what Rose asked initially, she asked that, how do you prioritize? You have been given a requirement. And that's the reason I told you that in your requirement, there will be things to state for you to know that this is a must have. Must have means it is compulsory. This is a should have. Either or. It's a nice to have. We can do without it. So, and we've got some that may use terminology like mandatory. When they use the word mandatory, it is compulsory. So they know that there's a reason it's compulsory. And some, you might even be reading through the requirement and see that this field is meant to be, or this requirement is meant to be mandatory. You can discuss with the business analyst to say, don't you think there's a risk in this one? If we don't test the payment platform properly, it could leave. There are consequences when we don't test properly. So I think the one you're putting as a nice to have, it shouldn't. Don't you think it shouldn't be? That's why we are there together as colleagues, is to help ourselves. So you can query that to say, why shouldn't we test a payment platform properly? Because if you don't test it properly and people are able to pay to get things and get it delivered free, it's loss. So you have to be careful. And people are able to log in or get an application for free. So those are the things that we need to validate. And I hope that answers your question, Alex.
Yes, it does. But is it the QAs that come up with the requirement, or yeah?
No. That's why I said initially. When I was talking about error, I talked about different people in the team. Business analysts are the one. Business analysts, the BAs, are the ones to come up with the requirement. You can't formulate the requirement. But having said that, I'm trying to be mindful. If you get to an organization where there are no BAs, where there are no product owners, where there are no scrum masters, where there are no requirements, you could look at the application or whatever they have on ground, and you can come out with some testing scenarios from there. I was practical to say it. I'm only giving you two sides of the coin. Most of the time, I'll say in my career for over 15 years, maybe two places, I would say. It's kind of difficult. I will still have something to play with, something to explore with that will give me that script. It might not now be detailed, which you can now be querying the requirements, but it is meant to be. Requirement gathering are done by business analysts. It is not your job. But if you can help, what is the help? You doing static testing. We are going to get to that phase when we are doing types of testing. So when you're doing static testing, you can ask your question when it comes to that. Yeah. So it can either be in fact, the business analyst, product owner are there with the requirements ready. So requirements can be in form of user story. It could be specification. It could be a BRD, business requirement document. It could be in a spreadsheet. So requirement specification. It could be in the tool, like Azure DevOps. So that's it. Any other question? So no question. So in the absence of no question, I'll say a very wonderful thank you to every one of you once again for your time this night. I'll meet you in the next class. It will be conveyed to you by the admin. And hopefully, please ask the admin for the soft copy of the textbook. Have a wonderful evening. Thank you.